Hello, everyone. Welcome back. I hope that you had an awesome spring break. It's been sunny out, which is really nice. Today, we are going to be looking at lesson 5.5, which is in your volume 2 textbook. This is solving inequalities using multiplication or division. So, to start, you should have already answered the solve and discuss it. This is on page 279 in your textbook, or I posted this in the lesson page. If you haven't tried to answer this yet, please pause the video and do that. Otherwise, I want to give you an option for how you might have answered this. So it says Alex and Hope were trying to solve negative 6x is greater than 24. Whose inequality shows the solution? Alex's work is x is greater than negative 4. Hope's work is x is less than negative 4. So there are many ways to figure this out, and your way was probably different than what I will show. But one way that you could figure this out is trying to find an answer that fits both Alex's and Hope's inequalities, and then seeing if it works in the original inequality. So for example, for Alex, if x has to be greater than negative 4, that means that we could say x could be 0, because 0 is greater than negative 4. So let's go now to the original inequality, negative 6x greater than 24. Okay, if x is 0, that means we would do negative 6 times 0, which is 0. That means our final equality would state 0 is greater than 24. I know that's not true. So let's look at Hope's work and see if hers makes sense. X is less than negative 4, so we're going more in the negative direction. So I'm going to say that means x could equal negative 10. Let's go to the original inequality. Negative 6x is less than 24. So negative, I wrote that down wrong. Negative 6x is greater than 24. There we go. So negative 6 times negative 10 would fit Hope's answer. And that is, well, negative times a negative is a positive. So that's positive 60. So our final inequality would state 60 is greater than 24. That, in fact, is true. So based on me just testing two answers that fit Alex's and then Hope's inequality answer, I found that an answer that fit Hope's works in the original inequality. So whose inequality shows the solution? Hope's shows the solution. Now, we are going to talk about why it's Hope's, because if you noticed, negative 6x greater than 24, but then our answer says x is less than. That inequality switched directions, which is weird because x is on the left side. So we're going to talk about why that is today. So first, example 1 is on page 280 if you're in your textbook, if you want to follow along there. And I also have assigned it on Pearson Realize if you'd like to watch that animation. So it says, Gina's pet potbelly pig is on a diet. Aw, he's a fat little pig, poor guy. He can have no more than 18 ounces of pig food per day. How many scoops can Gina feed the pig without going over 18 ounces? Okay, so his maximum amount of food is 18 ounces per day. That means 18 is the maximum. So anything that we feed the pig, which I'm going to write on this side of the inequality, has to be less than or equal to 18. Because if we said whatever we feed the pig is greater than, that means we could feed him more than 18. So it has to be less than or equal to 18. We could feed him exactly 18 ounces. Now, 4 ounces per scoop. Our question is, how many scoops can we feed him? So 4 ounces per scoop, those are keywords that lead us to knowing we have to multiply 4 by the number of scoops. If she does 1 scoop, that's 4 ounces. If she does 2 scoops, that's 8 ounces, 3 scoops, 16 ounces, and so on. So, how many scoops can she feed her pig? Well, 4s is less than or equal to 18. So let's figure out how many scoops that is. And just like we solve equations and what we learned the week before spring break, we're still undoing the operation. So 4s is less than or equal to 18. That's 4 times s. To undo that, I'm going to divide. I'm left with s is less than or equal to 4.5. Because 18 divided by 4 is 4.5. For these lessons, you can use a calculator if you have one available to you, and it can be a calculator on a phone also. Okay, so she can give her pig 4.5 scoops or less. The way we graph this is, since it's or equal to, I'm going to put a closed point at 4.5. And then it's going to be an arrow pointing to the left. Because she could feed him 2 scoops. That would only be 8 ounces. She could feed him 3 scoops. That would only be 12 ounces. So you could check and make sure what you graphed makes sense. Now this is supposed to be a dot that I'm drawing here, but it's really hard with my... That's a closed point, everyone. Now, real quick. This arrow is pointing to the left, but she can't feed him negative food. That would be like taking food out of him. I guess that would be like making bacon. Am I right? Anyway, so I'm going to say that it has to also be more than 0 because she has to feed him a little bit. Okay. Now, there's a tricky part of solving inequalities with negatives. And this is a simple example that if we were together in person, I would have done a little bit differently. But hopefully this will help you at least start to make sense of it. So the inequality I have up here says 2 is less than 11. If someone had 11 candy bars and I had 2 candy bars, I would have less than them. Yes, it's true. Now, you'll notice that I have a rule down here that says when multiplying or dividing by a negative, the inequality switches directions. So let's divide both sides of my inequality by -1. Remember, if we do the same thing to both sides of an equal sign, or in this case, an inequality sign, it keeps it balanced. Well, this would give us -2 and -11. If we kept the inequality the same, it would state that -2 is less than -11. But that's not true. If you are in debt $11 and I'm in debt $2, I technically have more money than you. So what happens is when we multiply or divide by a negative, the inequality switches directions because our negatives are opposite our positives. So that means the negative switches that inequality to be opposite. We have to switch it in order to keep that inequality being a true statement. So we're going to have to use this rule every time you multiply both sides of an inequality by a negative or divide both sides of an inequality by a negative. So this is going to be an example. Solve the inequality, -3.4m is less than or equal to 17. Just like with our equations, I'm multiplying by negative 3.4, so I'm going to divide both sides by negative 3.4. So I'm left with m. Now, see how I divided by a negative? My inequality was less than or equal to, but now it's greater than or equal to. And then I know that a positive divided by negative is negative, and I'm going to use my calculator. 17 divided by 3.4 is 5. M is greater than or equal to negative 5. So on my number line, I know negative 5 is between negative 4 and negative 6, so I'm going to put a closed circle here because it's or equal to, and greater than is going to be pointing this direction. One thing I like to do is use 0 as a check. So 0 is in my solution. It's in that arrow, right? So that means x should be able to equal 0. So let's check. Negative 3.4 times 0 is 0. 0 is less than or equal to 17. If we go back and check it in the original, it has to make the original work. So that works. Okay, and final example 3. Solve the inequality r divided by negative 2.25 is greater than or equal to 7. So remember, this looks like a fraction. A fraction is just division. This means r divided by negative 2.25. What's the opposite of division? Multiplication. So we're going to multiply both sides by negative 2.25. Multiply by negative 2.25. That undoes our division here, so we have r. Now we multiplied both sides by a negative. That switches our inequality. So now it's less than or equal to. And positive times a negative is a negative. 7 times 2.25. 7 times 2.25 is 15.75. So my solution is r is less than or equal to negative 15.75. So on my number line, I'm going to say this is negative 14, this is negative 15, this is negative 16, negative 17, and so on. Negative 15.75 is closer to negative 16. It's 3/4 of the way there. And if it's less than, it's going to be an arrow to the left. Less than left. Now, to check and see if my solution makes sense, I need to choose a number that would be in that solution set. So x equal negative 100 would be in that solution set. It's further to the left. So let's see. Check. We go back to the original. Negative 100 is in my solution set. Is negative 100 divided by negative 2.25 going to work? Well, I know a negative divided by a negative is a positive. That's good. 100 divided by 2.25 is 44.4 repeating. So 44.4 repeating is greater than or equal to 7. Check. It worked. Okay, so there are two options for practice. Your first option is to complete the practice and problem-solving problems. They are posted in the lesson folder, but they're also on pages 283 to 284 of your textbook. And the answer key will be posted in this lesson, so you can check your work. But if you can, and I think most of you can, I would very much recommend for you to log on to Pearson Realize. The instructions are on Schoology, and do the 5-5 Math XL for School additional practice that I've assigned you. The reason why it would be great for you to do that is it's online and there's help buttons that you can press as you're going, and it also tells you if your answer is right or wrong. So there's just a lot of help in that practice, because if you were working on this in a classroom, you would have classmates or me there to help you. And since you're doing it at home, having the help buttons to give you the next steps or to press a video will help you learn as best as possible by yourself. So lastly, after you do one of the two options, you could do both if you want to, you're going to complete the 5-5 exit ticket that's posted in this folder. And that will help me know how we're doing as a class on these types of problems and what I can help address further. Okay, thanks everyone.